Hello student, welcome to this lesson where we are going to look at conversion of masses to particles. Simply, we are saying conversion of masses in grams to the Avogadro's constant. The Avogadro's constant we already know, so we are going to use examples to make the concept clear. How many atoms are there in 20 grams of calcium? So we are being asked about the atoms and we have the masses. So what do we know about masses? We know that 1 mole has this Avogadro's constant, and for masses we know 1 mole has RAM, or maybe we have molar mass of 40 grams. So which are we going to use first? Since we are provided with 20 grams, we are going to using the second relationship, that is 1 mole in 40 grams. So we do a cross multiplication to know the number of moles present in 20 grams. After getting now 0.5 moles, now we move on to the first relationship, which says 1 mole is present in these atoms, that is the Avogadro's constant. But we calculated that the number of moles present is 0.5. So we put our 0.5 there. We ask ourselves, what about in this? How many particles or how many atoms? We do a cross multiplication to get this value of 3.0115 times 10 to the power 23 atoms of calcium. Second example, calculate the mass in 1.2046 times 10 to the power 23 atoms of iron. So there are two things we know about iron. 1 mole of iron has the Avogadro's constant, and 1 mole of iron have a molar mass of 56. So molar mass, since we are provided with the number of atoms, then we are going to use the relationship on Avogadro's constant. So 1 mole has this number of particles or atoms. What about 1.2046 times 10 to the power 23? We do a cross multiplication, then we divide with the Avogadro's constant. But before we conclude, it is important to note that when you are dividing using a calculator, make sure that you put the brackets so that you can get the correct answer. After getting the number of moles, use now the first relationship, which says 1 mole of iron has 56 grams. So what is the mass in 0.2? We put the mole on the mole side, cross multiplication to get 11.2 grams. Here is a quiz for you. You may pause to copy and do the calculations, and the answers are provided. We proceed on the next part, conversion of relative molecular stroke formula mass to moles. Relative molecular mass of an element or compound is the sum of all RAM of atoms present in that molecule or that compound. For example, oxygen, nitrogen, chlorine exist as gases, and so they exist as molecules. Their relative molecular masses are computed as follows. The elements, we have the RAM, we have the number of atoms in a molecule. So the relative molecular mass or molar mass is the relative atomic mass you multiply by 2, because they have 2 atoms, to get a mass of 32 for oxygen, 71 for chlorine, 28 grams for nitrogen. To make the concept clear, a mole of oxygen gas has a mass of 32, meaning there are 2 atoms, so 16 times 2, so 32 grams per mole And a mole of water has 18 grams. 2 plus 16 to get 18, because the formula of water is H2O. For ionic compounds, the term relative formula mass is used. Example: what is the relative formula mass of sodium hydroxide? Formula mass: there are 3 elements present in this compound, namely sodium, oxygen and hydrogen, with 23, 16 and 1 as relative atomic masses respectively. So the relative formula mass will be computed as follows: 23 plus 16 plus 1 to get 40 grams. So 1 mole of sodium compound has a mass of 40 grams. Example 2. What is the relative formula mass of magnesium chloride? This one has 2 elements, magnesium and chloride ions, with magnesium 24 and chlorine with 35.5 relative atomic masses, but chlorine are 2. So to get the relative formula mass, it will be 24 for magnesium plus 35.5 times 2, because there are 2 chloride ions, to get 95 grams. How many moles are there in 4 grams of sodium hydroxide? We know relative formula mass or molar mass of sodium hydroxide is 40. So what about 4 grams? So we put the 4 on the gram side. You do a cross multiplication to get 0.1 moles. Another example: how many moles are there in 1.06 gram of sodium carbonate? The first thing, get the formula of sodium carbonate. In case you have a challenge, refer to topic 2, topic 1 from 2, and a link will be provided under this video. So sodium carbonate has that formula because sodium has a valency of 1 and carbonate has a valency of 2, so they interchange to get Na2CO3. So the molar mass will be 23 times 2 plus 12 plus 16 times 3 to get 106. So 1 mole of sodium carbonate has a mass of 106. Therefore, we ask ourselves, what about in 1.06 grams? So you place it under these. So you do a cross multiplication to get 0.01 moles. Here is a quiz to test your understanding on this concept of conversion. There are 4 questions. Work them out and you're going to get the answers provided here. Thank you. Wish you the best.